Hi everybody, we're going to start on solving equations today with variables on both sides of the equal sign. So we had your quiz yesterday on equations with variables on one side. Most of you did fine. Some of you still need to work on the process of solving these equations. And we talked last week about how our first step should be to distribute, second step combine like terms, and then we solve for the variable. The difference today is we're going to have the variable on both sides of the equal sign. So my phrase when we solve these equations is I want you to plan ahead. Plan ahead a couple steps. There's a lot you could do, a lot of first steps that we could take to solve an equation like number one. But what I need you to do, what I want you to do is think ahead a little bit, all right? Our goal is to get the variables on one side and the numbers on the other side. So I either need to move this over here or this over here. I also could move this over here or this over here. As a general rule of thumb, I want you to think about moving the variables first. You can hear my dog's tags jingling. He's sitting up here helping me do math today. So move the variables first. And the reason I say that is because it's going to make our end game, our last steps, a little bit easier. So what we have here is we've got the minus 15, the minus 7. We're going to hold those off. And we want to think about which one of the 6n and the 4n do we want to move. And we could move either one. There's no correct answer here. There's no one right way to do this. But there is an efficient way to do this. And I want you to think for a second. We could either subtract 6n from both sides, and when we subtract it from its like term on the other side. I could do that. Or, alternatively, I could subtract 4n from both sides of the equation. Either one of those is correct, but one of them's more efficient, and that is this one, if I subtract the 4n from both sides. And the reason for that is, if I subtract 4n from both sides, 4n minus 4n on the right is 0. On the left, I get 6n minus 4n, which is 2n, which is a positive 2n. And it's easier in my end game, in my last step, to divide by a positive. My next line down that I would write would be negative 15 plus 2n. It's plus because positive 6 and minus 4 gives me plus 2n equals negative 7. Be careful here when you cross out that 4n. It's not just 7, it's negative 7. Okay, that sign is attached to the 7. Now we're down to just the variable on one side. This is what we did last week. We would add 15, 2n equals 8, and divide by the 2, n equals 4. So the idea here is think about an efficient first step. There's no one right answer. Some of you might have chosen to add 15 to both sides. That's okay. You would have added 15 to the 15 and added 15 to the 7. That's okay. Some of you might have chosen to add 7 to both sides. That's okay too. But it's most efficient if we move the variables first and we plan ahead. What's going to make our end game as easy as possible? All right, so lots of ways to start these. I want you to think, what's the most efficient way? Here's another equation. Again, we have n's on both sides, right? We could move the 14, we could move the 2 using inverse operations, but again, I want to move the variable first. I can either move the n or I can move the 3n. So I want you to think, which one would be a better step? I could subtract 3n from both sides, or I could subtract n from both sides. Either one of those will work if I follow through on my signs. But it's better for me if I keep that n, if I keep the coefficient of the variable positive. So I'm going to subtract out the n, and what that will leave me with on the right is a positive 2n plus 2. On the left I have negative 14, and I'll leave it to you guys to go from there. We'd get the same exact answer if we had subtracted the 3n from both sides, but the difference would be I would have negative 2n minus 14 equals 2, which is okay. My signs are just going to be complicated at the end. Either way is all right, but there's an efficient way to do these. And I am German, and Germans like efficiency, all right? So we want to look for efficiency here. we might see an equation like this number 4, and we notice in number 4 there are two different variables here, or two variables on the left. So my first step should be combine like terms. If I combine like terms on the left, I get a equals 12 minus a. And now again, I could move either one of those a's. I could subtract the a on the left, but things get a little weird there. I would end up with 0 equals 12 minus 2a. That's okay, I can do that. However, again, it's a little more efficient if I plan ahead a couple of steps. What if instead I added the a to both sides? And again, we add it to its like term on the left and the right. This goes to 0, and now I have 2a equals 12, and then a would equal 6. Okay, so efficiency, thinking about the best first move we can make there. Now we get a little bit longer equation. The idea is the same though. First thing we're going to do is distribute, then combine like terms, and then start moving those variables around. Okay, so again, just being really meticulous with our signs. Negative 4 times a, 8a is negative 32a. Negative 4 times negative 4 would be plus 16. Minus 7a equals negative 21 minus 2a. So again, the equation, a little bit longer, we distributed first. Next thing I'll do is combine the like terms on the left and on the right, and there don't happen to be any like terms on the right. So my right side is still negative 21 minus 2a. On the left, I have this minus 32a minus 7a, that's minus 39a plus 16 equals negative 21 minus 2a. Now I've combined like terms, so this is almost a clean equation. What I need to do though now is move the variables either to the left or to the right. So I've got a's here and a's here. Which one would make it easier in the end for me? I could move either one of those. Think about for a second, which one would be a better choice to move? I'm going to choose to move that 39 because if I add it, plus 39a, plus 39a, now my signs are easier to deal with at the end of this problem. I have 16 equals negative 21 plus 37a. And now, if you think ahead a couple steps, we can kind of see where this is going. I'll add the 21 to both sides. 37, forgot my a over here, 37 equals 37a. So a would equal 1. Okay, so it's distribute, combine like terms, move one of those variables either to the left or to the right through its inverse operation, and then solve. I'll do one more with you, and then I'm just going to have you practice some problems on a PDF today. So I'll do 2 more of these problems with you, I guess. I'm going to start with number 13 here, our lucky number 13, and I'm going to distribute first. So remembering that there's a 1 in front of those parentheses, I'll distribute. Next line down, I'm going to write negative k minus 2, and then I'll distribute this 2 plus 4k plus 8 equals 3k plus 6. All right, so I distributed. My next step is combine like terms. And my like terms here, I have these k's that will combine to 3k. And then minus 2 plus 8 is plus 6 equals nothing to combine on the right. That's 3k plus 6. And oh, look at this, what just happened. I end up with the left side equal to the right side. Well, the left side equal to the right side, I'm still going to follow through with the algebraic steps here, okay? What I said to do next is put the variables, move the variables. So I can either subtract 3k or subtract 3k. Either way, I'm doing the same thing on both sides. I'll subtract 3k on the left, and then from its like term on the right. But what happens here, in both cases on the left and the right, is 3k subtracts out, and I end up with 6 equals 6. Well, because the variable went away, this is one of our special cases. It's either an all real numbers or a no solution. Because this is a true statement, 6 is equal to 6. It will always equal 6. The left side will always equal the right side no matter what. Our solution is all real numbers. Okay, so sometimes that happens, and it's okay. We're going to carry that idea all the way through this year. We'll do one more together. I lied. Let's actually do two together. We'll do this one quickly and then do one with fractions, and then you can practice your homework, all right? So again, same idea. I'm going to combine like terms. I'm going to distribute, then combine like terms. On the left here, there's nothing to distribute. I can combine 5k and 6k is 11k, and then 1 plus 7 is plus 8. That will equal, on the right, if I distribute, I get 10k minus 5. Watching my signs here, that would be plus 15k minus 15. So 11k plus 8 equals 10k, and 15k is 25k. And again, watching my signs, minus 5 minus 15 is minus 20. Let's see. So again, I'm going to plan ahead. Which of those k's should I move first? I could move the 25k to the left by subtracting it. I'm going to get a negative number, though. If I move the 11k, all is well at the end of this story, because I'll end up with a positive number to divide by, and I'm less likely to make a mistake that way. So 8 equals 14k plus 20 minus 20. And again, we can start to see the end of this story. I'll add 20 to both sides, and that's nice because I get, oh, that's 28 equals 14k, so k equals 2. Okay, so distribute, combine like terms, and then move the variable, and then solve for x, or solve for the variable. And we'll do one more problem with fractions. Again, clearing out fractions, a huge method. Some of you missed out on that in the last week or so. Really big idea to clear out the fractions. And what I'm going to do is look through here, and I notice least common denominator of all those fractions would be 6. And I'm going to multiply through by 6. Remembering I have to multiply that x times 6 as well. So I have 6x minus 2 goes into 6 3 times. 3 times 7 is 21. 2 goes into 6 3 times. 3 times 1x is plus 3x. Same thing on the right. I'm going to multiply by 6. 6 goes into 6 once. 1 times negative 17 is negative 17. Gotta be careful to remember those negative signs in front of the fraction bars. 6 times a half is 3, so it's 3x plus 3x. And then 3 goes into 6 twice. 2 times 2 is 4x. Okay, so variable on both sides, but we can still use this idea of clearing out the fractions. So on the left, let's see, that's 9x minus 21 equals negative 17 plus 7x. And again, let me think about which one of those variables I want to move first. Do I want to move the 9x, or do I want to move the 7x? Well, in the end, in the long run, it's going to be easier for me if I move that 7x. So I'm choosing an efficient way to go about these problems. 2x minus 21 equals minus 17. And then I'll add 21 to both sides. Boom, boom, 21. And again, this is turning out nice and neat. 2x equals 4. And x equals 2. Okay, so that same idea of clearing out fractions applies for these longer problems with variables on both sides as well. All right, so check out the PDF, and you do not need to submit it. You don't need to upload anything. Just come with questions, and let me know if you have any questions. We'll check the answer key, and we'll just practice a little more tomorrow, and then it's the weekend. All right, talk to you guys. Bye-bye.